Hello, everybody, and today we are here for our week 1 lesson 2 on absolute value. Now, this is more like a mini lesson than anything. We're just reviewing how absolute value works, what it is. It is considered an operation, so like adding, subtracting, multiplying, dividing. It is an operation. Um, but it has a very specific thing that it does. Yeah. Um, the definition for absolute value, though, is the distance from zero. Oh my gosh, do you see it on a number line? Oh my gosh. Okay, who saw it? This right here. Does not say distance. The distance from zero on a number line. So if we go and look at this number line right here, I drew -5, 0, and 5. -5 and 0 and 0 and 5 are the same exact distance away from each other. -5 is just as far away from 0 as 5 is from 0. They are both 5 spots away. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're just in different directions. If you live in an apartment building like me, my neighbor to the right of me is just as close as my neighbor to the left of me. They're the same distance away from me. It doesn't matter that one is to the left and that one is to the right. I could just as easily walk over to either of their doors. Not that I am going to, because I don't think that they want to see me, and I am pretty shy, so I don't want to bother them. So what I'm saying though is that if I were to take the absolute value of -5, the distance from 0 that -5 is 5. The distance from 0 that -5 is 5. The distance from 0 that 5 is, the amount of times I had to move over to get to 5 from 0 is 5. Another way that a lot of students think about this is that absolute value makes negative numbers positive. The reason it does this, though, is because we're talking about how far away is this number from 0. That is what absolute value means. So if I go down a little bit, we'll look at an equation here. I have -3 plus the absolute value of -3 plus the absolute value of -5. So before I do anything, I want to rewrite this problem without those absolute value symbols. So the absolute value of -3, I'm going to rewrite this problem, is 3. -3 is 3 spaces away from 0. That is the distance from 0. Also, if I think about it in the other way, I am making a negative number positive, like I mentioned up there. So plus, there was a plus sign in the middle. The absolute value of -5, which we already said is 5. So now 3 plus 5, that is 8. -3 plus -5 would have been -8. So if I wasn't paying attention to those absolute value symbols at all, I would have said the answer is -8. That ain't true. That's not what I'm looking for. The answer here is just a normal an 8. For this next problem, I have the absolute value of 15 minus 23. I am going to do this operation first. We often treat these absolute value symbols like they are parentheses. So before, I'm not going to do like the absolute value of 15 minus the absolute value of -23. They are in the same exact absolute value sign. So I need to do what's inside these two lines right here before I do anything else. So 15 minus 23 is -8. So, oh my gosh, lots of, I swear I didn't make every problem's answer 8. So now that I did the 15 minus 23, I can deal with the absolute value. I realize I didn't say this already. Absolute value, the symbol for it is like these straight noodles, these straight little noodle lines. They look like ones if you're not careful. They are not ones. They are like bars, I guess, or noodle lines. Noodle lines. Um, Nice. So looking at our noodle lines down here, the absolute value of -8, if I were to draw a number line, 0 to -8, ooh, -8's right there. I'd have to go back 1, 2, 3, 4, 5, 6, 7, 8 times to get to -8. So -8 is 8 spaces away from 0. I promise this is a coincidence. Or maybe I just really like the number 8. Either could be true. You don't know me that well yet. So in PEMDAS, it is treated like parentheses. So it is one of the very first things that we deal with. So if we're thinking about order of operations, PEMDAS, the very first thing is we deal with parentheses or we deal with absolute value if it exists within the problem before doing any of the other operations. So if I have the problem 5 plus negative absolute value of -3 here, notice how I'm reading it from left to right, even when I just say what the problem is. That's the proper way to read a math sentence. 5 plus -3, before I can do this, I have to find out what the absolute value of -3 is. So I'll write the rest of my problem as it was. I had 5 plus. The absolute value of -3 is 3. So I am replacing this right here with 3. Now I can do 5 plus 3 and I get 8. This is a coincidence. I promise you. I did not plan this. Oh my gosh. This last problem, I swear, is not going to be 8. Um, Here I have 15 times the absolute value. I know that looks like a 1. These are absolute value symbols. Two little noodles, remember, noodle arms. Of -6 plus 2. The very first thing I'm going to do is, what is -6 plus 2? It is -4. You can throw that in a calculator if you need to. I don't. The absolute value symbols are still there. All I did was add the -6 and the 2. What is the absolute value of -4, you ask? It is +4. We take a negative number and we make it positive. Take a sad person and we flip their frown around and make it a smile. Now I can do the 15 times 4. This entire piece right here became a 4. That is simplifying at its best. 15 times 4 is 60. It's not 8. Thankfully, I didn't make it 8 this time. I swear that was on accident. So now we're done. We did 15 times 4. That was the multiplication down here. It's the only other step that we had, and we got 60. So our lesson, what we're taking away from this today, is that the absolute value is the distance a number is from 0 on the number line. It'll make a negative number positive. If you take the absolute value of a positive number, it just stays positive. The absolute value of 16 is 16. The absolute value of 8,274 is 8,274. So positive stay positive, but negative numbers turn positive. The moral of the story is, if you are ever having a sad day, just put some noodles outside your head and it will turn it into a positive one. All right, thank you everyone for watching. Have a great day. Goodbye, goodbye, goodbye.